Welcome students to the subject logic and distributed control system. Today we are going to start with the subject as an introduction, and these are the references we are going to follow to the entire course, that is wave and raise programmable logic controllers. So this is a very good book to understand the programmable logic controllers, and we are going to follow this book in details. And to understand the distributed control system, we are going to discuss the book called by MP Lucas, and along with that some of the other books like the elements of process control by Deshpande, process control instrumentation technology by Curtis Johnson, and also the instrumentation engineers handbook by Liptak. These are the books we are going to follow. All these books, mostly all the books are available in PDF, but I don't think that the wave and raise this book is available in PDF. And also the MP Lucas, I think Curtis Johnson and BG Liptak, these two books you will get in PDF. So most of you are thinking that what this course about, so what is the things we are going to learn in the course called logic and distributed control system. So one very important thing I can mention you here, that to understand this course no prerequisite is required. Only the prerequisite is that you have to have the knowledge of basic control theory. And another thing is that there will be no mathematics. Mostly we will be involved with some logics. So if you are understanding the logic, means mostly the basics of digital control, digital electronics, then you will find that this course will be interesting for you. So that's why here we are starting with about the course, what the course is about. Now you know that automation and control are important aspect of modern manufacturing and industries, in manufacturing and utility supply industries. So these are the two very important things, automation and control. Okay, so many manufacturing assembly lines and processes utilize programmable control systems. So it is essential to equip the prospective engineers in the field with the appropriate theoretical and practical knowledge. This course will extend your skill across essential areas in the field of automation and control. Using specialist equipment and software in our dedicated laboratories, you will learn to use distributed control system, programmable logic controllers, and supervisory control and data acquisition system, which is known as SCADA, and some industry standard communication protocol, that is field bus or modbus, for the development of effective control system. So these are the very important topic we are going to discuss. They are the distributed control system, programmable logic controllers, SCADA, and the industry standard communication protocol, that is field bus and modbus. So these are the four important topics you can say that we are going to understand in this course. So now, before going to the details about the introduction of this course, we want to know that presently where we are. Okay, so many of you have listened about the term called Industry 4.0. So this is the current state of art of the industry, you can say. So in 2011, the German government have brought into the world a new heading called Industry 4.0 or I 4.0, assumed as the fourth industrial revolution. Okay, so Industry 4.0 aim to work with a higher level of automation, achieving a higher level of operational productivity and efficiency, connecting the physical to the virtual world. So it will bring computerization and interconnection into the traditional industry. So already the traditional industrial communication as well as the automation was there, but what it will do, it will bring computerization and interconnection into the traditional industry. Industry 4.0 can be assumed as cyber physical systems production based on heterogeneous data and knowledge integration, and it can be summed up as an interoperable manufacturing process, integrated, adapted, optimized, service oriented, which is correlated with algorithms, big data, and high technologies such as Internet of Things and services, industrial automation, cyber security, cloud computing, or intelligent robotics. So many advanced technologies will be involved in this industry 4.0. So one common thing you are able to understand whatever we have discussed till now, that as a you have seen that about the course what I told, that many manufacturing assembly lines processes utilize the programmable logic control system to automate the system, okay, automate the process. So automation is a very important word you are finding that is playing to a key role in the industry. So that's why we are going to understand what do you mean by the automation and how it is correlated with the control. Now, derived from the word automaton, meaning self-acting machines. Okay, I think it is a Latin word, so meaning self-acting machines. It is a set of technologies that results in operation of machines and system without significant human intervention and achieves performance superior to manual operations. And what the advantage of automation, there are numerous advantages are there, maybe the improved throughput, improved quality, reduced cycle time or scan time, less human intervention, etc. So these are the several advantages are there with the automation. Now the question is that how we are going to achieve the automation. Now automation can be achieved with the help of feedback control system that already we have studied in last two courses, that is control system 1 and control system 2. So this is the conceptual block diagram of the feedback control system. You have the process which you want to control. So this is the process you want to control. So this is the process you want to control. Now the process having the input and outputs. So what do you mean by the process? Now process, you can say that it is a system which processes the inputs and produces the outputs. Now what we want to do, now we want to produce some desired output. So what we have to do now to get the desired output, the output has to be measured by sensor, suitable sensor. Now that sensor information and that measured output information is going to the controller. Okay, now the controller having the set point, maybe here the controller having the set point. Now with this set point, the measured value is compared and some algorithms are there in the controller. With that algorithm, the controller is going to produce a control signal, and which is executed through the final control element. So this control valve may be one of the final control element which is going to execute this control action on the manipulated input such that the desired output is achieved. So this is the mechanism of any control system, and here you are finding that in this way we are going to automate the process because here less human intervention is required to achieve the desired output. Okay, so now next issue is that in details what is the feedback control system. Okay, so you know that the feedback control system, that in details you can say that we have the plant is affected by the disturbance. Okay, so our objective is that the output of the plant has to be maintained at a desired value which is known as control variable. Okay, at its desired value even if the disturbance is there. So that control variable is measured by sensor. Now the output of the sensor is compared with the reference signal which is given to the controller. So this is the controller you have. Now controller is going to execute the control action which is executed by the final control element to the plant to maintain the control variable at a desired level. Okay, so even if these disturbances are there. So this is the work of any feedback control mechanism, already what we have understood from the previous courses. And from here it is also established that with the less human intervention we can achieve the desired output by the feedback control mechanism. Okay, now another important aspect is that where this control is implemented, then also it will be clear that how the revolution in the automation has come. Okay, so where the control is implemented. Now, to understand where the control is implemented, we will take the example of a control system where you are finding that, suppose we have a process. So this is a typical process what we have. Okay, so this is the process we have. Maybe we want to maintain the level of this tank. Okay, so this is the objective. Now what we are doing now, this process may locate at a at the process plant in anywhere, inside the process plant anywhere. So now this measurement, okay, the measurement of the level has to be sensed by a sensor. Okay, and that signal has to be sent to the central control room. Okay, because in the central control room the operators will be there. Now in previously, at the beginning, you will find that these signals, the sensor, what the signal is going to produce, and it is going to be transmitted from the field to the control room. So you can say that these processes are located at the field, and with the sensors, whatever the measurement we are going, that has to be sent to the central control room. Now with the sensor excuse me, with the sensor, whatever the signals we are measuring, how we will transmit to the central control room. At the beginning, this transmission has been done with the pneumatic signal. Okay, you know that standard was 3 to 15 psi was the range. Okay, was the range to transmit the signal, pneumatic signal, from one place to another, and later on it has been replaced by electrical signal, and that is current we use to transmit that one in the range of 4 to 20 milliampere. Okay, now this 3 to 15 psi or 4 to 20 milliampere are going to the central control room, and in the central control room you will find that to get the display of the measured variable, some conventional street chart or some analog meters were there, by which the operator can see or can measure whatever the value indicated in the field by the process. Okay, now inside this old style control panel, actually the controllers were there. The controllers, maybe the analog controllers, were there at the beginning. Later on it has been replaced by the digital controllers, maybe the computers. That we are going to learn, that revolution actually we are going to understand. Now maybe some controllers are going to sit inside this control room, and based on this measured data, measured value, the controller is going to produce a control signal, and that signal again has to be transmitted to the field. And at the beginning that was a pneumatic signal, that is 3 to 15 psi or 4 to 20 milliampere. Later on, when this pneumatic system was replaced by the electrical signals, so now this signal has to be executed by the final control element. Okay, final control element, to have the desired value. So now this was the entire scheme of a typical control system which is implemented in process industries. Okay, now nowadays you will find that this old style control panel has been replaced by a central control room by a modern computer based control panel. Okay, same thing, we have the process which is located at the field. Now the sensors are going to sense that measured value, and now it has been sent to a current signal, that is 4 to 20 milliampere, and now this 4 to 20 milliampere is going to a modern control room, and some control computations are there. In modern control room, the displays of variable, calculation, commands to valves are in centralized control center. Okay, and then whatever the control action is generated by the central control room by the controller, it is going to the final control element at the field. Okay, so now you see the previously it was a simple control panel, it was a control panel where the analog meters were there, or the strip charts were there, but now it has been replaced by a modern computer based control panel. Means more, you can say that the human machine interface has been improved. So now we have to understand how this journey has started and how we have reached to this modern control facilities. Okay, so nowadays you will find that this will be the picture of a very neat and clean, and several displays, modern displays will be there, and the operators are comfortably sitting to monitor the process variable, and also they are going to take some manual action with some emergency switches to shut down some process by sitting only here, or to change the set points, or to change the control algorithm they also can do by sitting at the control room. But now we have to understand how this has happened. Okay, how this revolution has been progressed. So this is a very important thing. Till now you will find that most of the means the courses dedicated in the control, we have understood how we are going to control, what are the algorithms, what are the mechanism we are going to utilize to control. But now most important thing is that where the control has to be implemented. Okay, so that we are going to also learn in this course. Now before going to understand the details about the how this where this control is implemented, another important thing we are going to understand that building blocks of industrial automation, because just now we have understood that what the automation means, and now we are going to understand how the automation has been built in a industry. Okay, so this is the typical industrial automation pyramid. You can say that at the level 0 the sensor and actuators are sitting, and they are going to interact the process and machine directly, and level 1 some automatic controllers are sitting, then in level 2 supervisory control, at level 3 is the production control, and level 4 is the highest level where the enterprise has been dedicated. Okay, so now here you can see that if you go from top to bottom you are going to have the more speed, and if you go from the bottom to top you are going to increase the responsibility. Okay, so now we are going to understand each of the levels separately. So first you are finding that in level 0 sensor and actuators are there. Okay, so we are going to understand about the level 0, but before that what the common thing has been stated about the automation pyramid. Various components in an industrial automation system can be explained using the automation pyramid as shown above. Here various layers represent the wideness in the sense of number of devices and fastness of components on the time scale. Okay, so first sensor and actuators layer, which is indicated by level 0. This layer is the closest to the processes and machines used to translate signals, so that signals can be derived from the processes for analysis and decisions, and hence control signals can be applied to the process. These forms are the base layer of the pyramid, also called level 0 layer. So what is the work of this level 0? Now this level 0 having the sensors and actuators, what the sensors are doing, the sensors are going to interact with the process and machines, and they are going to collect the data or the measured value, and that measured value is going to send to the level 1, which is used by the automatic controller, and now the automatic controller based on this data or measured value going to produce some control action. Then that control action again come to the level 0, which is executed through the actuators to the process. Okay, now next level is the automatic control layer. what the automatic control layer is doing. Now this layer consists of automatic control and monitoring systems which drive the actuators using the process information given by the sensor. This is called the level 1. Means all the automatic control like P, PI, PID all are sitting in the automatic control layer. Okay, so maybe the PLC, the programmable logic controllers, are also there in the automatic control layer. Based on the sensing signals, they are going to produce the control action which is going to drive the actuators. Okay, now most important thing is that the level 2 is the supervisory control layer. So this is a very important thing which we are going to learn in this course in new, that is the supervisory control. What is that? Now this layer drives the automatic control system by setting the target goal to the controller. Supervisory control looks after the equipment which may consist of several control loops. This is called the level 2. So now you see so this supervisory control, what it is doing, now it is going to supervise the all the automatic control loops which is present in the industry. Okay, maybe there are thousands or more than 1,000 loops will be there. Okay, maybe the flow control, level control, temperature control, many loops will be there in a factory or in the process. All will be supervised by a control mechanism which is called supervisory control. Okay, so you will come to know that the distributed control system or the SCADA comes under this supervisory control layer. So in this course we are going to understand, because till now if you want to see the subject wise, you see in your course, in your BTech course already you come to know the several sensors and actuators. You have studied the level 1 by studying the control system 1, control system 2 and process control. You have come to know that what are the control strategies are there. Mostly they are used in level 1, but now we are going to understand the level 2, that is called supervisory control. That supervisory control, now we are going to understand that how the functionality of the supervisory control has been developed such that higher level of automation can be achieved. Okay, and the production layer control, this solves the decision problems like production targets, resource allocation, task allocation to machine maintenance management, etc. This is called the level 3 layer. And the enterprise control layer, this deals with less technical, more commercial activities like supply, demand, cash flow, product marketing, etc. This is called the level 4 layer. Okay, means this production layer and the enterprise layer, mostly the superior managements, means superior level of managements are going to handle these two layers. Okay, means if you want to understand that, suppose a Reliance oil processing plant or the refinery, you are thinking that it is a whole process for them, then the Ambanis are sitting actually in the level 4 to look after the entire process. Okay, so you will find that as the levels are going to change, the humans involved in each and every levels and their responsibilities are also going to be different. Means what I want to say, that the operators who are involved in, or the engineers who are involved in level 0 and level 1, their responsibility will be different those who were involved in the level 2. And I told that the level 3 and level 4, most of the managerial persons will be involved to handle the production control and sitting at the enterprise to look after the entire industry. So this deals, that's why this deals with the less technical, more commercial activities like supply, demand, cash flow, product marketing, etc. This is called as level 4 layer or level 4 layer. Okay, so as we have understood the characteristics of the automated pyramid is that the spatial scale increases as the level is increased. For example, at the lowest level, a sensor works in a single loop, but there exist many sensors in an automation system which will be visible as the level is increased. Means several loops will be supervised by supervisory control levels. Okay, so as we will go from bottom to top, then the spatial scale increases. Okay, the lowest level is faster in time scale, definitely, because there the automation is involved only with a single loop, so that's why it will be faster. Okay, and higher levels will be slower. Why? Because the aggregations are there, because the supervisory control is going to look after the several loops, so that's why they will be slower. The aggregation of information over some time interval is taken at the higher levels. Also, we are not going to check the status or the health of each and every loop frequently when someone is sitting at the top level. Means, suppose as an enterprise, suppose Ambani is sitting at enterprise level, so he is not going to look after at the day by day that what happened to the flow control loop 1 or the temperature control loop 2. He is going to understand that in a year or in a 6 months, what is the loss, what is the profit, or what is the demand, what is the cash flow. So definitely he is going to take the aggregation of information over some time of interval, as he is sitting at the top level as a top level management. So this is the automation pyramid, and this has to be very important, because you will find that many things can be discussed if you remember this automation pyramid in future. Okay, and another thing is very important thing. The important thing is there how each layer is communicated with each other. So all the above layers are connected by various type of communication system. For example, the sensor and actuators may be connected to the automatic controllers using a point-to-point digital communication. The automatic controllers themselves may be connected with the supervisory and production control system using computer networks. Means you will find that several controllers are there in a factory or in a process industry. So then how they are supervised? They are actually connected through they are connected to a computer networks. Okay, some of these networks are proprietary. Okay, over the last decade, with the emergence of embedded electronics and computing and standards for low-level network standards, that is CAN bus, field bus, etc., for communication with low-level devices such as sensor and actuators are also emerging. So we are going to understand definitely what are the supervisory controls are there, and also along with that we are going to understand the communication protocol which is used in the industry, and they are most popular are the field bus and the Modbus. So we are going to understand in this course this communication protocols also. Okay, so I think I will stop here, and next day we are going to understand the hierarchical control. Means we want to understand that how the role of computer in the process control has been changed over the time. Then only we can understand that how the revolution has come in the industry in terms of automation. Okay, so that we are going to understand in the next class.